Hi, in the previous video, we talked about all these power pins. Now I will talk about the rest of the pins here. So first, I will start with those VSS. So we have three VSS pins. So VSS pins, they are the digital grounds, and you should tie all of them together. And then VSSA, it's the analog ground. Also, it should be tied to the ground. So from the data sheet, what they saying, that's what exactly they said. In all cases, the VCCA pin should be externally connected to same supply ground than VSS. So we ended up, as I said, to never split the ground. So you connect all of them to ground. So VCCA basically is the V reference minus. So if you want also to change the V reference, that's also can be possible. That's another subject. But in this configuration, our board will work perfectly. And we notice we don't. Uh, they're talking here about VDDA, and I don't have VDDA on my schematic. So that's because I didn't really add it. So VDDA is the same of uh, vref, so I should actually put here slash VDDA as well. And then VSSA is the vref minus, so I should also add that here. So then we have the last pin here, which is grounded, is the EB. So this is the exposed pad or the terminal pad, which is in the middle of the of the microcontroller. So as we know, this pin it's provide a solid ground connection for the STM, and also it's for the heat distribution as well. So we talked about it before. So we're done with those all pins. So now let's talk about this pin 44 MCU boot 0. So if you go to the same data sheet, you can see it can be configured as to the VDD or to the ground. So here they just put switch. So it means you can pull it high or pull it low. So pull it to the ground. This is the normal mode. It tells the MCU to boot from the internal main flash memory, which where your program is stored. Then for boot 0, if it's bullet to, for example, 3.3, so this is the bootloader mode. It tells the MCU to boot from the system memory. So this is the build in memory contains a program for STM that lets you load a new code uh, into the chip using interface like USB or UART. So let's see what else they provide information about this. So here they put you this table also. So we don't have boot 1, so we have boot 0. So this is 0, as I said, is the main flash memory. So in this case, when we put 0, so I put it to the ground. Then I'm working on boot from user flash mode. So this is the normal mode. It tells the MCU to boot from the internal main flash memory. This is where your program is stored. So in any case, this is mostly I always also use, and you can see all design they use this. But if you want to pull it high, so this is the bootloader mode. It tells the MCU to boot from system memory. So this is special factory programmed memory, contains a built-in bootloader from STM. So this bootloader, if you build it high, the purpose is to let your program the chip main flash using a simple serial interface like USB, UART, or I2C without needing a debugger. So it's just more special cases here. If you want to pull it high, you can read about those two cases. And again, I bought 10 kilo ohm. So this is what STM they suggest to put 10 kilo ohm. So that's what I did here. I put 10 kilo ohm resistor here. So also if we go to this table 11 in the same data sheet, so we're still on this AN data sheet, then you can see clearly they wrote MCU might not work probably if the boot 0 and boot 1 are floating. And this is, and then we connect it to the ground. So this is a good also table if things doesn't work, then they suggest what is the problem. So you can also follow this table. So that's all about this boot 0. Let's back to our design. So then this Vcap1. So this Vcap basically the STM32 has an internal regulator that convert the voltage from the VDT down to 1.2 volt to power the CPU core and the digital logic in the STM. So it's an internal regulator. Our STM it has just to power the internal circuit. And this pin, if you can see here, I connected to 4.7 nanofarad. Let's see what the data sheet said, because I made a mistake here. So Vcap here, Vcap1 and Vcap2. So we only have one Vcap in this STM. So they should connect it to 2 multiply with 2.2 microfarad with low ESR. And then if you have one, it should be 4.7 with low ESR micro. So I just put nano here, so I can just change it. And then I wrote a clear note here. It should be C13. It should have a low ESR. So that's the purpose of this bin. We don't do anything about it. Instead, we just connect it like this. And then as a software, he can also, the software designer, he can also disable this internal regulator or enable it. But that's more a software side. So the last pin in this video is this NR reset. So this is the main reset pin. Its only job to force the microcontroller to restart its program from the very beginning. So every time you upload your program to the microcontroller, it will reset by this pin. Then you see I have C14 connect to the reset pin with 100 nanofarad. And also I have a resistor which is not fit resistor. So now making my board, I will just keep this empty. Let me show you here. So this is the recommendation. That's what we used here. You can also implement an external uh, button to reset manually your board, but I didn't do that. I don't need a reset button. I can just upload the code again and it will reset automatically if I have any issues. So as you can see, the chip itself, it does have internal pull-up resistor, and I put a pull-up resistor which is non-fit. But because this pull-up resistor, sometime it's a weak pull-up and make the pin very sensitive to noise, and small clutch could easily case a random reset. So I just put this for safety. So if I have issues, my PCB is suddenly reset, then I can place this resistor, and then I will be sure that this pin is always pull to high. So that's the only reason I put this resistor here. So it's just for safety. So far we covered all this 3.3, the power supply. So you can see I have 1, 2, 3, 4, 5, and I have here also 5 decoupling capacitor, and also I have the 6th one is the bulk capacitor. And then we also covered all these pins here. So the only thing is left is the crystal. So I will talk about the crystal in the next video. Thanks.